Good morning, students. Myself, Dr.BADI ALEKHYA, Associate Professor, Department of Artificial Intelligence and Machine Learning, R.M.D. Engineering College. Today, we are going to discuss one of the language model under text processing and speech analytics, NGRAM language model. We have three types of language models: statistical language models, neural language models, and pre-trained language model. Under statistical language model, today we are going to discuss NGRAM language model with one example. So consider the problem statement. I love machine learning. Machine learning is amazing. I love deep learning. Here we have to construct unigram, bigram and trigram frequency distributions for the given corpus, and also we have to compute the probability of the sentence I love deep learning using bigram model. So let us move and split the given sentence into given corpus into words, individual words, and calculate the frequency, how many times I repeated, how many times love, mission, learning, and capital mission. So here the mistake. So capital L, learning, easy is for one time, amazing for one time, deep is for one time. If you observe, you can understand the frequency of words in the corpus because it's bigram. Now move to the, it's unigram. Move to the bigram frequency. So combinedly, how many times that word is repeated? Let us see. I love is repeated for 2 times combinedly with joint bigram. Here 1, here 2. Love mission only for 1 time. If you observe here, like that, machine learning, two words at a time, and capital M machine learning 1 time. Learning is, after learning is only 1 time is repeated. It's bigram. Is amazing 1 time. Again I love 2 times. Love deep 1 time. Deep learning 1 time. So in this way, same like this, we are going to calculate for the trigram. I love mission 1 time. Love machine learning 1 time. Learning machine learning 1 time. Is amazing 1 time. Love deep learning. I love deep learning 1 time. In this way, we are calculating the frequency for this question, constructing unigram, bigram and trigram frequency distributions. You have to construct frequency table like this for unigrams, bigrams. Unigrams is taking one word at a time, bigrams taking two words at a time, and trigrams taking 3 words at a time, and calculate the respective frequencies based on the corpus. Next, for the second question, compute the probability of sentence I love deep learning using bigram model. Okay. So how we are going to computing bigram model using MLE. MLE for bigram model, if you are seeing, this is the equation Wn by Wn minus 1. It is representing current word. This is representing previous words. So for the bigram model, computing for I love deep learning, count of Wn minus Wn minus 1 comma Wn divided by count of Wn minus 1. So if we are considering 2 words at a time, under bigramming we are considering 2 words at a time. If we are considering 2 words at a time, I love, count of I comma love divided by, what is the previous word here for love? I. That word I am considering count of I. If you move to the frequency table, I love coming for 2 times, I coming for 2 times. Therefore, the probability of love by I is 1.0. Now for after I love, we are going to consider love deep. For love deep, current word is deep, previous word is love. So count of current word, previous word comma current word, previous word wn minus 1 is love and the wn is deep and count of wn minus 1 is love. So this n minus 1, n minus 1. Now we are going to check what is the frequency of count of love comma deep. In diagram model, if you are seeing that love comma deep is repeated for one time and count of love same you are seeing in unigram frequency it is 2. Then what is the probability here? Count of love comma deep, the frequency is 1 and the count of love is 2. The probability of deep over love is 0.5. Now we are going to calculate last two words. First combination is I love, second combination is love deep and third combination is deep learning. So in deep learning, according to the formula, the current word is learning, the previous word is deep. The current word represents WN, the learning, the current word learning represents WN, the previous word of learning represents WN minus 1. What is the previous word of the learning? It is deep. So that's why you are writing the probability of learning slash deep. Now we are going to perform the step P of learning over deep. So equal to count of that is wn minus 1. wn minus 1 is deep. What is the previous word deep? What is the correct word? wn is learning divided by count of wn minus 1. The wn minus 1 represents deep. Now you calculate the probability of count of deep comma learning. That in diagram deep comma learning repeated for one time and for deep 1. Therefore 1 divided by 1 probability. They asked to compute the probability for diagram probability for I love deep learning. Therefore you can multiply all these three probabilities and get the probabilities for this given sentence. So final probability is probability of love over I, probability of deep over love and probability of learn over deep. So the probability of this diagram model is 0.5. So that's all for the today's session, students. We will meet with some other new concepts in the next session. Thank you all.